Hello my dear students, welcome back to my class. In the series of learning programming in C, in the previous video we discussed about direct recursion. We have seen the dry run of the program and actual execution also. In today's video, we will discuss about indirect recursion. What is this indirect recursion and how the program runs with this indirect recursion process, the dry run of the program, actual execution of the program, all these things we'll see in today's video. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. And if you like the video, please click on the like button and share the video to all your friends. Your support and encouragement will be a motivation for us so that we can come up with new videos. So what is this indirect recursion? The name itself tells you. So the recursion process is nothing but the process wherein which we call the same function again and again. It's a process in which a function calls by itself. If it is calling by itself directly, so it is direct recursion. That's what we have seen in the previous video. Please do check out the playlist. But if it is not calling directly, there must be some indirect call. So for example, if I say I'm calling myself, I just say Yashoda or I just say Yash, I call by myself. I call Yash. So again, Yash, I'm calling myself. But this is direct recursion. If I call, say, Varun, Yash is calling Varun and Varun may call some other name, say Bimba. And Bimba may in turn call Yash. So this is indirect. Or if you want to make still simpler, I say Yash calling Varun and Varun in turn calling Yash. This is indirect. Let me write in an example form, in the function form. Say for example, let me treat these as functions. Say function 1. Say function 1 and calling. I have some statements. Then inside function 1, I call function 2. I call function 2. If I call the same function 1, then it is direct recursion. Right? If I don't call function 1, I call function 2. Then what happens? The control will be to function 2 somewhere here. So here I have function 2. Okay. So function, say function 1, say function 2. So function 2 will have some statements. Inside function 2, what I do? I'll call function 1. Then what happens? The control will be to function 1. Okay. Function 1, I'm calling function 2. When I call function 2, the control will be to function 2. Inside function 2, I'm calling function 1. So now the control is back to function 1. Again it goes on. But where I can end. So again we should follow the base case and recursive case. So hope you have understood this. This is what? Indirect recursion. A function calling one more function. That one more function calling once again the same function. This is what? Indirect recursion. So let us have a complete example for this and understand how this indirect work, that is recursion, is going to work. So here we have a very simple program to understand the concept of indirect recursion. Let me tell you the flow first and then we'll get into the actual execution or the dry run of this. The flow we will understand first. So here we have two function declaration. One is function 1, I have written as fun1, function 2, fun2. Return type, it is integer for both the functions and only one argument which is of integer type for both the functions. Then here we have the call to function 1 in the main function. Function 1 call gets invoked, the control we will have to function 1. Inside the function 1, we will have the call for function 2. Okay. Inside function 1, we will have the call to function 2. When I come to function 2 call, the control will be to function 2. This is what the function 2 code. When I get into the function 2, I'll come here and I'll call function 1. If base case not satisfied, here also. Base case not satisfied, obviously I'll come to recursive case. In recursive case, I'll invoke function 2. When I come to function 2, again I'll check with base case. If base case not satisfied, control to recursive case. In this recursive case, I am calling function 1. Look it here. Function 1, I came here. Function 1 to function 2, function 2, I came here. When I get inside the function 2, see here, I am calling function 1. So again, the control is back to function 1. The control is back to function 1. Again, the process continues. So this is what indirect recursion. One function calling one more function. And that one more function calls the same function again. See, I called function 1. When I come to this called function, here I am invoking function 2. When I come to function 2, I am again calling the same function 1. So let us see the dry run of this. Then we will understand clearly how the indirect recursion process is taking place. So forward process, backward process, that we need to keep track very carefully. Okay. Now, so as usual, declaration in this main. So we have two frame of memory, one for the main function and the other for the sub function. So we have the stack, memory stack. Inside the stack of memory, we will have all these statements. So totally how many statements we have? 1, 2, 3 and 4. Here also 1, 2, 3 and 4. So let us see tracing now. Now printf result equal to, straight away we can print the result through function call. This method also we can do. We have seen that in the previous videos and all. Okay. So I am calling the function. This is declaration, this is call, and this definition for two functions, function 1 and function 2. So now I am calling function 2. Which function? Sorry, function 1. I am calling function 1. Function 1, I am passing the constant value. So it is 5. So I am invoking function 1 of 5. So immediately I will come to this function 1. This is what function 1. N is receiving how much? It is 5. So I have, this is actual argument and this is formal argument which is receiving the value 5. If n less than or equal to 1, what is the value of n? It is 5. The first statement I am executing, 5 less than or equal to 1. Is 5 less than 1? No. Condition not satisfied. Statement 2 will not be executed. That is written 1 will not be executed. I will come to else part. Statement 3. Then when I come to else part, statement 4 says written, I'll say written n into, what is n? It is 5. 5 into, see recursion, in the recursive case, this is base case and this is recursive case. The recursive case will always be the simplest form of the function. So here, when I get inside the function 1, I am calling function 2 in this recursive case. So I say 5 into function 2 of n minus 1. So it is 4. So I am calling function 2. So of 4, function 2 of 4, the control will be to function 2. N is receiving how much? 4. So here I will come to function 2 of 4. So function 2 of 4, again all the 4 statements. So the first statement it is going to check is 4 less than or equal to 1. No condition not satisfied. Come to the else part. Then the fourth statement, so I say written. It is 4 into, look at here. Recursion, this is base case, this is recursive case. I say 4 into, which function? It is function 1. So it is 4 into function 1 of n minus 1 means it is 3. Now the control is back to the same function, function 1. Okay, so when I come to function 1, again the same 4 state. This is indirect recursion. Function 1 invoked function 2 and function 2 is invoking function 1 once again. Got it? So I just call Varun and Varun will in turn call me. That is indirect recursion. So function 1 of 4, again back to the same function. So here I am calling function 1 of, not 4, I am sorry, it is 3. So it is n minus 1. 4 minus 1, it is 3. So now n is receiving how much? It is receiving 3. It is receiving 3. So function 1 of 3. Again, all the 4 statements. Is 3 less than or equal to 1? No. Condition not satisfied. I'll come to else part. Then I'll say return how much? This n value. 3 into here the recursive case function 2 of 3 minus 1. It is 2. So I am calling function 2 with the value how much? 2. So now I am calling function 2 with the value 2. So here I am getting function 2 with the value 2. So check the condition. 2 less than or equal to 1. Condition not satisfied. Come to the else part. I say return. It is 2 into function 1. Function 1 of 2 minus 1, it is 1. So I am calling function 1. Again the control back to function 1. So I am calling function 1 with the value 1. Again check. Look at here. I am coming to this block. 1 less than or equal to 1. Now the base case is getting executed. Base case is true. 1 less than or equal to 1. Yes. Condition true. So this statement return 1 gets executed. So I say return 1. Return 1 to the place. See, all forward process I did. Forward call I did. Now I have to get backward call. So I have to say, see here, function 1 is calling function 2. Function 2. Function 2 is calling function 1. Function 1 I'll come. Function 1 is calling function 2. Function 2. Function 2 is calling function 1. I'll come to function 1. Function 1 now, the base case is true. Now that is a termination point. I have to stop somewhere else. If I go on calling, see, Yashoda is calling Varun and Varun in turn calling Yashoda. Yashoda is calling Varun. Varun in turn calling Yashoda. There must be some termination point, right? That is what we are doing here. We went through a forward process. Now we have to go in a backward process. So return 1 where? To the place where this function 1 was called. Backward here. Function 1 return 1. Return 2 into 1 which is 2. To the place where this function 2 of 2 was called. Function 2 of 2 here. It is 2 into 1, it is 2. Again 2 into 3, it is 6. Return this to the place where function 1 of 3 was called. So here I get 2 into 3, it is 6. Again return 6 into 4, it is 24. To the place where function 2 of 4 was called. So function 2 of 4 here, it is 24. Return 24 into 5, it is 120. Return this 120 to the place where function 1 of 5 was called. Where this function 1 of 5 was called, it is here. Return 120 to this place. So my final result, I will be getting result equal to percentage d, print the value of this function call. So what was the value I got from this function 1 of 5? The value I got, the return value is 120. This is what you are going to get. You can have a message or you can simply say percentage d print function 1 of 5. So this is what the dry run. So this forward process and backward process you need to understand. If you understand this forward process and backward process, then recursion will be very simple to you all. But one thing that what you have to do is you have to write down this tracing. Then only you can understand. So that's all with this dry run. Let us see the actual execution of the program.
Indirect recursion. So here we have two function declaration, function 1 and function 2. This is what the main function. So inside the main function, what we are doing, we are calling the function 1 with the argument 5. The control will come to this function definition part, function 1, where we have the base case here. This is what the base case, and this is what the recursive case for function 1. So here when the base case condition gets checked, if it is not satisfied, it will come to recursive case. So in the recursive case, just observe here, we are calling function 2. Function 1 is called from the main, the control will come to function 1. When I come to function 1, the control will come to function 2. When the function 2 call gets executed, the control will be to this function 2. So it will be for function 2. So here the control will be for function 2. In the function 2 again we have the base case. This is what the base case, and here we have the recursive case. So here what happens, when I come to this function 2, if the base case is not satisfied, the control will be to recursive case, where in the recursive case I am calling function 1. Again the control will be to this function 1. Again function 1 gets executed, function 2, then function 2 I'll come here, then again base case not satisfied, again call function 1. It goes on like this. So once the base case condition gets satisfied, the recursion stops and we'll get the result. So let us execute this. So let us save this program first. Alt F9, control F9. See, the answer is 120. This is how the indirect recursion works. Hope you have understood with that. With complete tracing in the dry run itself, we have seen the execution here. I want you people to write down the complete tracing of the recursion. Then only the recursion process gets easy for you. So once you know how the forward process goes and how the backward process goes with recursion, there is nothing with the recursion, then it will be very easy for you to understand. So that's all for today's video. See you in the next video. Till then, take care. Bye.